Hey, greetings and welcome, friends. Man, we got to talk about what we remembered over vacation, but let's now talk about things that we're learning right now. Mis amigos and I, we were just doing some geometry sketchpad, and we realized some relationships between parallel lines cut by a transversal. If I look at these angles, we already knew that vertical angles were congruent. We already knew that linear pairs were supplementary. But now we're recognizing, wait a minute, these corresponding angles, they seem to be buddies. Wow. Man, classic. And that's also true for these corresponding angles. That's actually weird that I'm dragging the label and the point simultaneously. Good times. So we have some theorems as a result. Actually, back in the day, let me tell you this. Back in the day, 10 years ago, when I started teaching geometry, Ryan, this actually was called the corresponding angles postulate. This used to be. That's what I'm telling you. This used to be the postulate. We used to assume that corresponding angles, when you have two parallel lines cut by a transversal, that those would have been congruent. They've now put it in the theorem category, and we will be proving this in, I think it's chapter... No, it used to be chapter 7. Because we'll prove it using transformations, which is... I don't remember, it might be chapter 5 now. Back in the day, it used to be chapter 7. So they're going to prove this later for us, but for now, it's okay if you put it in the postulates category for yourself. So, corresponding angles theorem, right, says that if you have corresponding angles in a parallel line transversal situation, then the pairs of corresponding angles are congruent. And it says in the diagram at the left, oh dear, guys, what diagram? Oh dear me. Dear. Oh, dear. All right, look at this. I'll just tell you what. The diagram fits here, and it's at the right. So now this doesn't even make sense anymore. They're saying that angle 2, all right, Liam, Ryan, is going to be congruent to angle 6, and angle 3 is a vertical angle to that, and that's going to be congruent to angle 7. How about 1 and 5? Those will be congruent to each other, not to the original sets. And 4 and 8 will be congruent to each other, and those were vertical angles to that other set that I talked about. So corresponding angles, they are just congruent to each other. And if the angles are congruent, then their measures are equal. Good times. So the alternate interior angle theorem. Sometimes, by the way, we might abbreviate this as CAT. I might call it CAP sometimes because I'm used to it being a postulate. But this next one I like to call IT. You get it? Yeah. Classic. Which says that alternate interior angles are also with the congruence. Wow. So alternate interior angles theorem, alternate would be like this one and this one are alternate interior. And notice, oh, those are congruent. And you'll be able to prove it using vertical angles mixed with CAP. We'll probably do that in, I'm guessing, example 4 today. Yes, freaking way, actually. Yes. We're talking about angles right now. I don't know, actually. But alternate interior angles, check this out right here. Bam, 109.37. Those alternate interior angles, man, good stuff. Look at that. They are with the congruence. And so are their buddies. Well, actually, they're probably mortal enemies. But these two are buddies. Right, look at that. Definitely. I don't know. We'd have to define acquaintance. They might, like, be Facebook friends, but yeah. Alternate exterior angles theorem. Let's see, let's get another little graph in here. Look, I can make it so tiny. Oh, it's adorable. Yeah. So, alternate exterior angles are also going to be congruent. So that would be like angle 1 and 8 and angle 2 and 7. So yeah, that's pretty good. Let's oh, I forget that spacebar does that. That's nice. That's nice. So let's look at a pair of these alternate exterior angles, and oh man, I thought I could. Here we. Oh, why isn't it doing the thing where I select multiple things and drag them? No, it is. There we go. So notice that these two angles are congruent to each other, and they are the alternate exteriorist of angles, as well as these fellas right there. So those are congruent to each other. And then the last, yeah, this one you might call eight, maybe. Yeah, alternate exterior. And Chiat, consecutive interior angles theorem. Don't let it fool you, friends. These are not congruent to each other. Consecutive interior angles, actually I should label it this way, are going to be supplementary. They add up to 180, right? Bam, bam. Hundo 80 to each other. And we also labeled that on our geometer sketchpad sketch. Look at these guys, right? Oh, they're always adding up to 80, 180, 180. Good time. So now that we've defined these types of angles, and now that we've put them in the situation of parallel lines cut by a transversal, we've discovered, well, I've told you, and we've kind of manipulated Geometer Sketchpad, we've determined that there are some properties, some theorems about them. And so let's see. Let's put it to work. It says the measures of three numbered angles are 120 degrees. Identify the angles. So if this is 120, who else is 120? And could you give me an explanation for it? Draw a card. Ryan, you're saying angle 5. Why is angle 5? No, these are parallel. Yep. Corresponding angles theorem mixed with then def of Kong, right? All right, that angle 5 is going to be congruent to this angle by corresponding angles theorem, and then by def of Kong, if they're congruent angles, their measures will be equal. All right, what's another one, friend? Let's see. Liam drew your card. What's another angle that's 120 degrees? All right, so measure angle 4 is equal to 120. What's your reasoning? Multiple approaches here. Alternate. All right. I got you. All right, so alternate interior angles theorem mixed with def of Kong. Ryan, what do you... Oh, slow down. I agree. So this logic applies because I happen to know angle 5, and you knew that 4 was 5, and this was that, and so yeah, so you could have proven it that way. Is there another way I could have proven this if I didn't know angle 5 yet? I don't think so. Linear pair with what? Wait, whoa, friends, we're friends here. Which angles are a linear pair? No, I think it's just vacation. But we'll remember it's vertical angles is what those ones are when they're opposite of each other like that at the same intersection. So vertical angle theorem, def of Kong, would have been an alternative way to have come to that conclusion. And then lastly, what is the last angle that's 120, Emmett? Angle 8. And how might that be verifiable? Yep, so since we know 5, we could use that and then def Kong. Or corresponding angles with 4 and 8. Man, I was just going to write cap, but it's cat. Def of Kong. And what's another way I could do it? If I didn't know 4 or 5. Alternate exterior with the original 120. Alternate 8. And then def of Kong, right? So multiple explanations. There's lots of ways that we could have come to those conclusions. And then, of course, once you get the geometry, they're like, hey, what if algebra showed up to this party? And you're like, this is so great. My friends, algebra and geometry are hanging out together. Oh, man, this is amazing. Right? And so it says find the value of x. All right, they've labeled this little angle 4 here. What are you guys thinking here? Yeah, Emmett? All right, so by that, these two are congruent. Yeah, and I kind of did a substitution here simultaneously. Linear pair postulate. Let's see, so x plus 120 equals 180, and then, aha! Right, yeah, it's all right, we'll get there, so yeah, x equals 60, so you knew the angle measure, and then it's just a matter of the justification, right? So vertical angle theorem, and then this was consecutive interior angles theorem. With a little bit of subs there, I kind of threw this in there using subs. Yeah, and then just subtraction, or property of quality. Right, classics, the classics. All right, here we go. How about un otro problema? Now, don't just assume that angles are always going to be congruent to each other, right? This one was a case where they were supplemental. Let's look at example 3 together so you guys can write this down at home as well. Are these corresponding angles? No. This one and this one would be corresponding. It looks like they threw a name here for a reason, so what would the relationship between this one and this one be? Right, those would add to 180 because of LPP, right, linear pair postulate. Alternate exterior angles theorem would say that this one and angle 1 are congruent, and therefore this plus 136 is going to equal 180. Well, you could have found the measure of angle 1 first, is what you're describing, and then set 7x plus 9 equal to the 44. I agree. That's one way you could do it. Multiple approaches sometimes in math, and as long as we all obey the laws of math, Liam, we'll all eventually get to the same destination. 9 plus 136. Yeah, isn't it great though? It's great. Nice, easy ease back into geometry from vacation. You know what I'm having a hard time with for some reason? Adding 9 to 136. What's that, 145? I'm guessing. All right. All right, we have a possible answer being optioned in. All right, we've got some concurrence. So x equals 5. And also just make sure that you're answering the question that they ask. That's the classic, right? I'm like, x equals 5! And then I think I'm done, but maybe they ask me for the angle measure and not the value of x. That's the classic mistake. All right. Ooh, guys, we got a proof. I knew it. This is what we wanted, right? You're like, Mr. Wadi, this is so easy. We're bored. Bam! Here we go. Example 4. Wow. All right, so we are going to try to prove this. All right, we've got massive excitement. The crowd is going wild right now. It says, prove that if two lines are cut by a transversal, then pairs of alternate interior angles are congruent. They've pre-labeled some, pre-named some things for me. Let me set up the classic. Well, wait, was it like a 3-column proof? What was it called, guys? Oh, a 2-column proof, man. Where we're going to have our statements and our reasons, because we believe things because of reasons here, right? So let's see, statement. Right, you could say statement P is parallel to Q is given, right? Right, that's a good start. It's cut by a transversal. Let's see, based on this, now I'm proving alternate interior angles theorem. We're going to believe that CAT is already true. We're gonna believe that's already been proven. And so I'm gonna say that angle 1 and 3 are congruent. Well, I'm trying to prove this, so I can't cite itself in its own proof, yeah. So this is true because of corresponding angles theorem. I think I could then prove that 3 and 2 to each other. How is that true? From the cat to the vat, right? No, we don't have a dog theorem yet. Def of gong, dog. No, that doesn't work. Doc could be def of Kong, though. Man, I could have been calling it Doc this whole time. So let's see. And now, do you guys think I could make this claim? How could I make that claim based on previous statements? Transitive property, if 1 is congruent to 3 and 3 is congruent to 2, then 1 is congruent to 2. Or substitution, whichever way you wanted to think about it. Right. So I'll call this trans/subs. All right. Either of those justifications are legitimate. Ooh, guys, rainbow. Here we go. You guys are going to be excited about this one. Example 5. Except you guys have a black and white paper in it. But look at this. Vibrant rainbow colors. Ooh, when sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. Magic. I don't know. Maybe it has to do with the refracting off of the... And also, rainbows are actually circles. Yeah. You can see full circle rainbows or double rainbows and things like that as well. Actually, Mr. Perrin might know. He was asking, why are rainbows arced and not straight lines? I was assuming it had to do with like the curvature of the water droplet that the light is refracting from, maybe. And we also mentioned that they're circles.
Right. Well,
yeah.
Think about it.
Right. Yeah. Right, they're circles. And so the pot of gold is the journey in finding the end.
Yes,
and it's not the... Wow, okay. So if sunlight enters the drop and bounces away, for violet light, it bounces at an angle of 40 degrees, this is saying. So if angle 2 here is 40 degrees, what is the measure of angle 1, friends? So you're saying measure of angle 1 equals 40 degrees, and why? It's interior because it's... Yeah. It's interior because it's between the two parallel lines of, or the assumed parallel lines of those rays of light coming from the sun, and it's on alternate sides of the red line. So that's the, yes, like we said, alternate interior angles theorem, right, would say that those are congruent, and if the angles are congruent, then their measures are equal. All right. Very good, friends. Very good. Yeah, def of Kong would be the final conclusion there. Thank you, thank you.